I've got an interesting geometry question here. We have 4 circles, and we know what the radii are for the larger circles. And the question says, what is the radius of the small circle in the middle? Feel free to pause the video and have a go first. Otherwise, let's get stuck straight in. So geometry questions can always be pretty intimidating when you first look at them. It's often not super clear what you start by doing. So to help overcome that, I've got a geometry problem solving guide. We always start off by drawing a huge picture. In this case, I've already got one. Then label everything in the question. So here we've got the radii labelled on that we know. Let's label on the one we're trying to find. So I'm going to give the thing we're trying to find R. Now, step 2, we're going to draw lines connecting important points. Important points are things like the centres of circles, or maybe where lines intersect. So let's think about the centre of this circle. Let's start by connecting it to the centres of the other circles. And while I'm at it, I'll just connect all of them. Where else could we connect this point to? Well, we've also got the centre of this smaller circle, so let's join that one up. And to me, it makes sense while I'm at it. I can also do the same with this centre and this centre. Let me just do that now. Okay, so I think this point is connected to all the sort of points of significance, and same would be true for these two as well. What about the small circle? Well, we've connected it to the centres of the bigger circles. What about some other points? So I also see these points here where the circles touch as being significant. So let's also join the centre of this circle to those points. What I'm also going to do now is actually do some labelling here. So I've drawn some lines on. These dashed lines that I drew on, they're made up of different radii around. So let me label those. So I've drawn on lots of labels. We certainly might not need all of these. It's just to make it clearer in my head when I'm looking at different parts of this diagram, what we know. So all these sections are radii of various circles, which is quite nice. So this line, we know, has length 105 plus 14. What else does our problem solving tip guide say? It also says, can you make right angle triangles? Now, we like right angle triangles because we know things about them. In particular, Pythagoras' theorem often comes in handy. So let's have a look at if we could put any right angles on this diagram. If we look at this sort of triangle here, it feels like this should be a right angle, but obviously it's not enough just to think that. Can we know that for certain? Well, actually we can, because this line that we've drawn here from the smaller circle, this is acting as a tangent to both of these circles. And I think we have a theorem that says that if you have a radius meeting the edge of the circle at a tangent, then it meets at a right angle, which means that this angle is a right angle and this angle is a right angle. Likewise, if we think about this line here, again, it's a tangent here now to these two circles. So this is a right angle and this is a right angle. And again, over here, we have two right angles by this tangent line. So this is quite nice, as we've made quite a few right angle triangles. But which ones have the most information? Well, these bigger ones, actually, we know 2 of the sides with no unknowns. So if we consider this side of the triangle, we have a side length that's 105 plus 14, which is 119. We've got a side length here of 105, and this is a right angle, so by Pythagoras' theorem, we can definitely work out this side length. So we don't actually know right now if it's going to be immediately useful, but as point 3 says, calculate and label anything we can. So that's something I feel confident we can calculate and label. So let's just do it. So our friend Pythag would say a squared plus b squared equals c squared, where a and b are the shorter sides of the triangle and c is the longest side. Let's say that short side is our a. We would have 105 squared plus, so b is the one we're trying to find, equals c squared, which is 119. So b squared equals 119 squared minus 105 squared. I'm just going to use my calculator for this, equals 3136. So b equals, so the square root of that is 56. Now I should note that if b squared is this number, then b is actually going to be plus or minus this number. Quadratic equations always have 2 solutions. However, because we're in the context of a geometry question and we know that b is positive, it's a length, so it has to be positive, I'm just taking the positive answer here. I'm not even mentioning the negative one, but I might just do that to acknowledge that I recognise there are two solutions normally to an equation like this. So we've worked out this missing side length. Let's label it on. What should we do next? Well, when in doubt, think what our friend Pythag would do. He would just look for more right-angled triangles. So let's see if he's onto something. We've looked at one of the right-angled triangles. Are there any more we can do? Well, we've looked at a big right-angled triangle, and we've also got these smaller ones around. Let's pick a different one. So let's just pick this one, for example. So this is a right-angled triangle. We've got our right angle here. We've got one length here, which is 105. This length, well, it's 105 up to this point, and then there's an r. So this entire length is 105 plus r. What about this side? Well, we know a lot of things about this line, this full line here. So we want this length, which has got some unknown length, there's an r, and then there's another r here. This is length 14, and we know the full length is 56. So 56 minus 14 minus r is the length we want. So our missing side length of our triangle is this. So using Pythagoras' theorem, we can connect these three sides of the triangle with an equation that involves r. We've got our a and b being our shorter sides. So let's say a is 105, and our b is this side here, which we've just worked out in terms of r. So that was this length, subtract this one and this one to get what was remaining. So that's 42 minus r all squared equals c squared, which is our longest side, which is 105 plus the r. So let's expand these brackets and simplify our equation. So we've got 105 squared plus here, remember, a set of brackets squared is the same in this case as being like 42 minus r times by 42 minus r, and you times by all the combinations of things across the brackets. I'm going to do this quickly without writing it out like that, but of course if you want more practice and you want to be more careful, do write it out fully and make sure you've covered all the combinations. We're going to have this first term squared, this first term times by itself, so 42 squared. The second term squared, so minus r times minus r would be plus r squared. And then two lots of the two things in the middle times together. So minus 42r minus 42r, which would be minus 84r, equals 105 squared plus r squared, and then two lots of the things in the middle. So 105r plus 105r would be 210r. Let's do a bit of rearranging here. So actually we've got 2 plus r squareds, so I can subtract plus r squared from each side and they'll just vanish. So let me bring all the numbers onto one side and all the r's onto the other side. So we've got 105 squared plus 42 squared, and then this number here minus 105 squared, that's another term we could have cancelled, equals 210r plus 84r. These cancel. So we're left with 42 squared, which I'm going to use my calculator for, which is 1,764, which equals, combining these two terms, so 210 plus 84, that is 294r. So now, if we divide both sides by 294, we'll just get r on its own. And if I use my calculator for that, we have 1,764 divided by 294. We get 6, so a nice number. So 6 equals r, or put the other way around, r equals 6. So that is our answer. We've successfully found r. So the main takeaway is just don't be afraid to get stuck in when you see a geometry question. Draw, calculate, label, anything you can, and just see where it takes you. Thanks for watching, I hope you enjoyed this video. If you want to see more aesthetic mathsy videos, do check out my channel and subscribe.